Right, the function f has domain to infinity and is defined by this here. Okay, f of x is 1 over root x minus 2. And it says then part A, write down the range of f. Okay, so the domain is to infinity. So let's see where 2 goes to. 2 goes towards this. Okay, and when we put that in, okay, when we put 2 in, actually doesn't exist, doesn't it, on our calculator? Because if you put that, you're dividing by 0. Alright? Now, when you've got awkward cases like that, what you can do is realise, of course, looking at this here, 2 isn't actually included. So it's understandable that sometimes you can't do it, okay? Okay, so it's obviously shooting off to infinity. But what we can do, because 2 isn't included, everything up to 2 is included, so what we could do maybe, because we can't work that out, we could put 2.00001 in or something like that to see what happens. Okay, and use our calculator. Okay, so if I put that on my calculator, right? Hope you could see there. Then let's have a look. Root 2.0001 take away 2. Okay, you get quite a big number, don't you? Okay, so you can imagine now what's going on. It's going to shoot towards infinity, as I said, as we get closer to 2. Okay, so that's quite a big number already. If I increase the zeros there, okay. Of course, what's happening here is if I increase the zeros, and you take away then 2 wholes, you end up with a very small number here, and square root it. It's a really small number. So 1 divided by a small number then is massive, and you gets to infinity. Okay, so put infinity in. Okay, as we get towards infinity. Okay, of course, taking away 2 doesn't make any difference. Square rooting doesn't make any difference. 1 divided by a massive number, basically, 10 to 0. Okay, so your range will be 0, infinity. Okay, part B then, it says find an expression for the inverse function and state the domain and range. So, remember now we write it like that. Okay, just like in the last question then, we could swap these two. Okay, and then because I want to get x equals, I need to square it. Okay, square both sides if you want. Square this side to get x minus 2, square that side to get this. And then x will equal, now here I would just square top and bottom, because if you square 1 there, you just get 1, square the bottom, you get y, so y squared, and then we're going to add on 2. Okay, so therefore f to the minus 1 of x equals 1 over x squared plus 2. Okay. The domain and range, well, the domain is just the range, isn't it, of the original function, and the range will be the domain of the original function. Okay. Part C then, it says show that the equation f to the minus 1 of x equals minus 3 over x has no solutions. And one thing you've got to be careful here is to actually understand what's going on with this question. They're not saying that this is what f to the minus 1 of x is. Okay. We've got that already, haven't we? We know f to the minus 1 of x is this, yeah? Okay? It's not this, right? Okay? It's this, isn't it? That's our inverse function. But they're saying here, we've got an equation, right? And they're saying, look, when the inverse function is equal to this, they've got no solutions. So what we need to do is, instead of having that now, write it as what it is, okay? So 1 over x squared plus 2, and put it equals to minus 3 over x. Okay, that's what we need to do. We've got that there. So we need to solve this, right? That's what it's saying, solve it. And we've got x's on the bottom, so we need to be careful here. What I would do is try and get the x's on the top. So multiplying through by x squared, a complete sort of sweep through by x squared, and we'll have nothing on the bottom then, no x's on the bottom, because you'll have x squared on the top here over x squared. If we times that by x squared, times this by x squared, you get 2x squared, and times this by x squared, you get that. Simplify it, x squared over x squared is 1, that's just 2x squared, and indices then, x squared divided by x is just x. So you end up then having therefore 2x squared plus 3x plus 1 equals 0. Okay, so he's saying show that it's got no solutions. And one thing you can do, of course, is check the discriminant. If you remember the discriminant from C1, okay, and the discriminant was the b squared minus 4ac, if you remember, from the formula. method, because you can solve this, can't you, using the formula method. And this bit here, part of the formula, was what was under the square root. So if this turned out to be positive, then of course you knew you were going to get solutions. You were going to get two distinct solutions because you could square root a positive. But if it was negative, then of course you couldn't square root it, because you can't square root a negative, so you have no solutions. So maybe this is what's going to happen here now. Let's see if this comes out as negative, we know we're not going to get solutions. So that's your A, remember, that's your B, that's your C. So we've got B squared, which is 3 squared. Take away 4 times A, which is 2, times C, which is 1. So if you work that out, that would be 9, take away 8, and that's actually equal to 1. So it's positive, which means there will be solutions. Okay, two solutions exist. Okay, two distinct as well solutions, they'd be different, because that's positive, they'd be different. So what's going on here? Because they did say that there won't be solutions. Okay, we've got to show that there's no solutions, and that's a bit of a worry, isn't it? Because they say show that there's no solutions, and yet discriminant says that there will be two solutions. So what I would do now is just try and find out what these solutions are. Okay, so we factorize it. Okay, and if we factorize it, we will have two brackets. Okay, and they both plus. That's what you get when you factorize it. And then let's see our solutions. 2x plus 1 equals 0, or x plus 1 equals 0. So x will equal minus a half, or x will equal minus 1. So we've got solutions. There's something going wrong here. But then we realize actually everything is actually in place, everything is going good and fine, because notice your solutions, they were both negative, weren't they? Right? They were both negative. And look at what we're dealing with here. We're dealing with the inverse function of f. And if we take the inverse function of f here, okay, which is what was part of the equation, look at its domain. Its domain is positive. Okay? So the solutions come out as negative, but we can't have them. Okay, we can't have these values. Okay, because domain of the inverse function is positive. Okay, therefore, if we can't have these values, there are no solutions. Okay, we've answered the question.